All right. So one of the cool things, well, one of the interesting things about this sort of data space, and this has actually been done a long time, but it's really been democratized, right? Before you tended to either do everything in a spreadsheet, which was very democratic, but not very rigorous, and repeatable, or you did it in an expensive tool. So one of the interesting things is now we have a lot of tools that are reachable by people that are technical with low cost. And so I'm going to example I'm going to use is actually COVID vaccinations by country. We're going to use the Our World in data sets. They actually gather COVID vaccination numbers from all the countries' websites as they're posted, and they pretty much update their site every day. Now, one of the interesting things about that is the country data is out of sync with each other. They all report on their own schedule. They tend to report slightly different numbers maybe, and Our World in Data tends to massage that back. But let's talk about some of the problems by the time it gets to us. If we want to do an interesting plot, where do we get jammed up on this? So let's look at two fake countries, country one and country two. Country one, the green country here. Let's look at their data. What kind of problems? So this data we're going to plot is from the 25th to the 30th. The first two values are missing. So that's a problem. And then it turns out on the 28th, we're missing one of the values that we want to plot, not a number. And then they haven't provided the 30th date. By the day we're running this report, they're missing their last day. And what we're trying to do is we want the data for all the countries to line up on a per day basis so we can get reasonable graphs. And if we want to do certain other kinds of operations with reasonable comfort, we can do that. And what'll happen is the data might get filled in later. So we'll rerun the report, so we'll rerun it and we'll catch up. In some cases, the data never will come back. Like if the data on December 25th wasn't generated, I don't know whether it means those didn't happen, but it's unlikely they'll go back and correct, but they might. In case of country two, we have every field for every day that they provided information. Country two is amazing here, right? Like it's pretty clean. Oh, but we have a problem. For some reason, we didn't get any data on the 28th and 29th. If we want to compare two countries or kind of do this aggregate thing, the problem is for our purposes, it's good enough if we can kind of fill in the data to make the countries align so that we can look at them in a fashion that is reasonable. It may not be 100% accurate, but we don't have any information. So we're going to take our best guess on it. So let's look at country one after we, what are we going to do with it? So the very first line on the 25th, if you don't provide us initial data, I'm not sure what we should do. We could extrapolate from the 26th and the 27th, trying to back into it. In my case, if it's a initial set of rows, I just didn't extrapolate. I'm going to leave it the way it is, and we just don't have any data in the beginning. For certain problems, that won't work. Now, on the 28th, we have data on the 27th and 29th. We're just going to interpolate. We can use different algorithms for this. In this case, I just picked kind of halfway. But you could do curve fitting. So if something was on the way up, you could actually adjust this interpolation for where you expect it to be. Although in this case, So, and then the last row, I didn't even have a last row. So in my case, what I'm thinking is I don't trust what the extrapolation will do. I'm going to take the position, and you might not, that end rows that aren't filled don't get filled. So I'm going to create a day, but not put anything in it. Those are going to be nans. That actually should say nan in the chart. Okay, on the blue side, it's kind of interesting. So we have all the beginning and end rows, and all the data has been supplied. What I'm going to do there is we're going to fill in the 28th and 29th and guess what the values are. We're going to do some type of curve fit against the original values and fill in the two data columns. When we're done with this, we will end up with 6 days of data for the two countries that line up with each other. But there'll actually be 4 days in the middle that we can actually use for doing graphing. In the other case, you'll just see C2 will show up earlier and later than C1, right, with values. So what is the algorithm we're going to use for this? The algorithm we're going to use is we start our notebook. In this case, I did all this in Python. It's amazing. Like, I'm not even a Python person, and you can do some pretty interesting stuff with not much code. So we're going to load the CSV file, which has got the Our World of data in it. And then we're going to create records for every missing day for every country so that every country has every date. And then for all the missing data in between other rows that has data, we're going to interpolate. And then the last thing I did is, if it's a string column, a lot of those are constant. Like, what's the country's ISO code? What's the country's website? I just B-filled. So if it was, like, if this far right column was the country's website, we just B-filled and F-filled for that. And so we're going to assume the website's the same in these. And whatever this one is, the second one is, all the blank rows before that are going to get filled with that country's website, same website. And all the rows that are blank after the last country's website will just get filled. And that's because I don't need to do any math on that. I'm just going to fill them. So constants were fit. We create all the empty rows, then we interpolate, and then we fill the values that make sense. Okay, so we're going to do this in probably a different video for the code. So how did this work out? So let's look. I generated some results. So the initial data set had 3,430 rows in it. And this is for the February 17th. And I had daily vaccination data in 3,300 of those rows. So we're missing daily vaccination data on 100 rows. And the total vaccinations with data. So that column, so I had two columns, daily vaccinations with data and total vaccinations with data, total vaccinations that had data. We ended up with 2,259. So it's interesting. We have more rows with daily vaccinations than we have the total vaccination totals. So somebody didn't add them up, but they provided what the vaccinations per day were, which is sort of interesting. And then the vaccinated per 100, we only got that for 1,227 of those. And I think we have to know what the population is, and the other thing is that vaccination per 100 is completely vaccinated. And so we end up derating the number of the daily vaccinations as how many shots are given. So we have a little bit of a mixed bag here. So then we go and we fill in all the rows. All right. So originally we had 3,430 rows. Now we have 6,038. So it turned out there were like 2,700 missing rows in the middle, or missing, a lot of them, sometimes they're missing in the early. Some countries didn't start shots till later than others. So all those rows for the 200 countries that are in the data set end up, some of them end up filled in the front and the back, and some of them end up filled in the middle. So we ended 2,700. And we didn't change the number of daily vaccinations or the number of total vaccinations data we had, or the vaccinations per 100. All we did was fill the blank rows. And then we went and did interpolation. So we had 6,000 rows after the row addition, and we had 6,000 rows after interpolation. What was interesting is we ended up, through interpolation, we picked up an extra 300 rows of daily vaccinations, which means we interpolated 300 days worth of data, about 10%. So that actually makes the graph look a lot better, and it's probably reasonably accurate, unless it's a holiday, in which case we messed up. And then total vaccinations, we went from 2,259 to 3,747. So in that case, we added 1,500 total vaccinations. So what that means is a lot of countries were reporting for some period of time just their daily vaccinations, and they didn't have totals. And what I could have done here is math, right? We could have added the daily vaccinations and done a running count into totals. Instead, I just interpolated it, okay? And it's probably close enough for what we're doing. And then the vaccinated per 100, we only had 1,200 rows out of 6,000 that had that reported, and we ended up with 1,600. So we ended up adding 400 guesses at what the vaccinations per 100 were. And again, we could have done this math. We could have done the row fill and then interpolation on the raw rows, and then any of the derived ones like total and vaccinated, we could have taken a different route and actually done math on it. I just interpolated it because it wasn't clear that we knew enough to make all the math work correctly. So, and for the purposes of the graphs, it's probably good enough to give us a feel for what's happening. So that's it. This Python code, it's all done in Python, and you can always go to this repo, but I hope this was informative and gave you some feel about how we would make COVID vaccination data align with each other so we could get some pretty pictures out of it.